Hi, this lesson is on identifying linear equations. So identifying linear equations. So just to start with, what is an equation? An equation in math anyway is a statement that a term is equal to another term, or a bunch of terms is equal to another bunch of terms. So for example, the statement 2 is equal to 2 is an equation because this equation plainly says that the number 2 is equal to the number 2. Okay, but you're more likely to be exposed to equations containing variables, like an equation of the form x equals 2. And now x is a variable here and 2 is just a number, but this equation is telling you that the variable x is equal to 2. And you must have come across equations like y equals 3x plus 1. Again, this is an equation and it's a statement that a term is equal to another term or another bunch of terms. So the key takeaway here is just the form of equation being a statement being equal to another statement. Anytime you see any statement of this form with an equality sign, you have an equation. So of all the equations that exist in the world, equations that take the form y equals mx plus c, where m and c represent constants and y and x represent variables, equations of such a form are known as linear equations. You might be wondering what m and c being equal to constant means. Well, a constant, as used here, refers to numbers, real numbers, such as the numbers -1, -2, even 0, 1, 2, 3, 4, and so on. Any real number, just emphasis that 0 is included. Well, a variable is just a holder. Okay, let me put it this way. A variable can take any value. A variable can take any value. Just think of it that way. But that's not what we're focusing on yet. And now we're just focusing on the fact that a linear equation is an equation that takes this form. You can see that it is an equation because it has an equals to sign, and it's saying that this is equal to this. Y is equal to the term mx plus c. You can tell that it's an equation. I've written these terms also in an equation form, but emphasis on this. Now let's look at examples of linear equations. Here's one. Equation y equals 3x plus 2. Let's compare it to the form it needs to be, because this is an equation. It needs to be of this form to be a linear equation. Let's see if it is in fact of this form. Make a comparison. By looking at the two equations, you can tell that m in our given equation, which this is the equation of focus, m in this equation is actually 3 and c is 2. And how can you do that? Well, if you look at the two equations, just by comparing the terms which occupy the same position, you can easily tell. But the proper way to do it is to compare the coefficient of x in both equations. Here, coefficient of x is m. In our equation, our example equation, the coefficient of x is 3. Therefore, for our equation, m is 3. And just by comparing the constant term, you can see here we have the term involving x plus a constant term here, the term involving x plus a constant term, where our constant term is 2 again. So let's put it this way. Linear equations take this form: y equals mx plus c. For the case where m is 3 and c is 2, we have a specific instance of this general form, because this is the general form of equations, and that instance is where m is 3 and c is 2. And this equation for this scenario is the equation I gave an example. Now let's look at another equation. The equation y equals 3x minus 2. Is this an equation of this form? Is it a linear equation? Well, you can see a y term, you can see a y term, you can see a term involving x, so a constant times x. Here again you have a constant times x. Remember, m is a constant. Then we have plus a constant term like 2, 3, 4, whatever. Here we have minus a constant term. So is this equation linear, given that there's a minus here? Well, in fact it is, because of the following. Now, if you have an expression a minus b, where a and b just represent any number, a minus b is the same thing as a plus minus b. Why? Because essentially what you have here, let's do this, a minus b is, or in fact, you might not believe, some of you already get it, but in case you don't believe, let's see 4 minus 2. What is 4 minus 2? 4 minus 2 is 2. But we're saying that's also the same. It's also the same as saying 4 plus minus 2. What is 4 plus minus 2? Well, plus times minus is minus. So 4 minus 2 is 2 as well. So going from this root, we get 2. Going from this root, you also get 2. So this you need to accept as a fact. In this case now, we have 3x minus 2. Well, that means this equation, the right hand side can be written as 3x plus minus 2. In fact, I could just say this categorically, that anywhere you see a minus sign in front of a number, you can always place a plus sign before that minus sign and you will not change anything. It's always accepted in maths. So now we have y equals 3x plus minus 2. Now comparing these two equations, so let's see, you can tell that m is 3 and c is minus 2 just by comparing the coefficient of x, m, 3, the constant term, plus the constant term. Here we have plus a constant term. Minus 2 is a constant term. Minus 2 is a number. Remember, constants are numbers. So that means that this is the general form of a linear equation, and this equation here is the instance where m is 3 and c is minus 2, because if you just replace m with 3 and c with minus 2 here, you get y equals 3x plus minus 2, which is y equals to 3x. Plus times minus is minus. Y equals 3x minus 2, which is the exact equation we have here. Here's another example. Is the equation y equals minus 3x plus 2 a linear equation? Is this equation of the form y equals mx plus c? Yes, it is, because as you can see, just by comparing the coefficient of x in both equations, you can see that m, the coefficient of x here, is equal to the coefficient of x here, which is minus 3, and c plus the constant term plus 2. C is 2. So this equation is the instance of this general form where m is minus 3 and c is 2. Moving on to another example, the equation y equals minus 3x minus 2. Is this a linear equation? Is there an equation of the form y equals mx plus c? Well, minus 3x minus 2 is what we have here. We can rewrite this as minus 3x plus minus 2. Why? Because we are trying to make the forms match, so we want to have a plus sign as well, and you know that plus times minus is minus, so this essentially is the same as y equals minus 3x minus 2. Now when you compare this equation to the general form, you can tell that plus constant term c is minus 2, and m is the coefficient of x, in this case minus 3. So our equation here is the instance of the general form where c is minus 2 and m is minus 3, because if you take the general form and replace m with minus 3 and c with minus 2, you get minus 3x minus 2, which is the original equation we had in the first place. So this equation is the instance of this general form where m is minus 3 and c is minus 2. Being a general form, it means that it captures all possible linear equations. All you have to do is just assign m and c values to get specific instances like this equation here. We have a few more examples to go through. What about the equation 3x plus 2 equals 0? Is this a linear equation? Is this an equation of this form, the general form of all linear equations? Well, in fact it is, because, okay, let's try and even compare it. Y equals mx plus c is the general form we're trying to match. Now this equation, in the general form, the term involving x and constant term on the right hand side. Here the term involving x is on the left hand side. So let's swap the left hand side of this equation with its right hand side. And doing that gives 0 equals 3x plus 2. Now no rule has been broken, because this is just an equation and it's stating that 3x plus 2 is equal to 0. That's the same thing as saying that 0 is equal to 3x plus 2. Nothing has been changed, because we're just saying they're equal to each other. Now, if you compare the equations, you can see that the coefficient of x here is 3, so m is 3. plus the constant term plus 2. So c is 2. Now you see 0 and you see y on the left hand side. This means that y is 0, m is 3, c is equal to 2. And here's a final example. The equation minus 3x minus 2 equals 0 is of this general form. Well, let's do what we just did in the previous video. Let's have this x term on the right hand side. So imagine we just swap this whole left hand side term with this right hand side term. We have 0 equals minus 3x minus 2. The original equation said minus 3x minus 2 is equal to 0. We're saying, well, that means 0 is also equal to this. 0 is equal to the original term. No rule has been broken. Now, as you recall, the constant term in the general form has a plus sign before it. Here we have no plus signs. So we can just apply the trick that I mentioned earlier. Place a plus before this minus sign. It doesn't break any rule. Plus minus 2. And now we have an equation of this form, because if you compare it to y equals mx plus c, you can clearly tell by comparing the coefficients of x, m is minus 3 and c is minus 2. Of course, y is 0. So in the given equation, which was minus 3x minus 2 equals 0, this given equation is simply an instance of this general form where m is minus 3, c is minus 2, and y is 0. And you can easily obtain this equation by replacing m with minus 3 in the general form, c with minus 2 in the general form, and y with 0. Doing so gives 0 equals minus 2, which is the original equation we had in the first place.